This is 6.2 of algebra. So we've solved systems of equations using graphing. Now we're going to use substitution. So if you think of substitution in terms of sports, in terms of soccer or basketball, right? When you get a sub, that's when you go out and someone else comes in for you and they go into your same position, right? If you send out a defender, you're going to put a defender back in, right? If you send out a forward, you're going to put a forward back in. You're not going to take a forward out and put a defender back in, right? That doesn't make sense. You only send them out when they're the same position. So let's look down here at this problem. So this second equation says that y is equal to x minus 1. So what that's saying is y is the same thing as x minus 1, right? If it helps to think of a balanced scale, they're both equal. So what that means is I can take this stuff, the x minus 1, and I can plug it in for that y in the first equation because they're equal, right? They're the same thing. So I'm going to plug it in. So I get x minus 1 equals 2x plus 7. And now I only have x's in my equation, so I can solve it. So I'm going to subtract x from both sides. I get that negative 1 is equal to x plus 7. And I'll subtract 7 from both sides. So I get that x is equal to negative 8. Remember, that's not your final answer. You need to go back and plug it in. You can plug it into either equation because we need to get our y, right? A solution is a point. So we need an x value and a y value. So I'm going to take that x equals negative 8, and I'm going to plug it into the second one. So y equals negative 8 minus 1, which is y equals negative 9. So our solution is the point negative 8, negative 9. Okay, so we've got another system. It's down here, but I'll write it up here. So 6y plus 5x equals 8, and x plus 3y equals negative 7. Okay, well here's our problem, right? We don't have a variable alone. I don't have something that just says it's equal to some expression. So I need to do a little bit more work before I can substitute. So what I'm going to do is I'm going to take this second equation and I'm going to rearrange it so that I get my x alone. Right? Why did I choose my x over my y? Well, my y has a number in front of it, right? And my x, well, it has a number in front of it, but really, when there's not a number, remember it's a 1. So it's going to be a lot easier to get x on its own than getting y on its own, because if I tried to go for y, I'd have to divide by 3, right? And it's just going to get a little messy. So I'm going to solve this second equation for x, which means I need to get rid of this 3y. So I'm going to subtract 3y. And I get that x is equal to negative 7 minus 3y. Okay, now I've got the x on its own, and I know that x is equal to this stuff, right? X and negative 7 minus 3y are exactly the same thing. They're equal. So what I can do is I can take this blue box, the negative 7 minus 3y, and I can plug it into my first equation for my x. So I'm going to rewrite that equation, 6y plus 5, and instead of x, I'm going to plug in negative 7 minus 3y, and it equals 8. And now I'm going to solve it because I only have y's in there. So the 6y can stay on its own, but I need to distribute that 5 in. So 5 times negative 7, that's negative 35. And 5 times negative 3y, that's negative 15y. So on the left, I'm going to simplify. I've got 6y minus 15y, which gives me a negative 9y. Still got my minus 35 equals 8. So I'm going to add 35 to both sides. And I get negative 9y is equal to, if I add those together, I get 43. And then I'm going to divide both sides by negative 9. And I get that y is equal to, well, if I do that on my calculator, I get 43 divided by negative 9 is negative 4.7 repeating. Here's an idea, though. I'm not going to write this as a decimal, because this is not my final answer, right? My answer is not just y equals 4.7 repeating. I still need to plug this back in. And here's the problem if I rounded it. If I round it and plug it back in, it's not going to be as exact. I'm not going to get exactly the right answer. So I'm going to leave this as a fraction. Negative 43 ninths. Okay? And then I'm going to plug that in as a fraction to figure out what my x is. And then at the end I can round them. So I'm going to plug into this equation right here, the second one. You could plug into this one, the one that we rearranged, but I would advise against it because sometimes you don't solve it exactly right. You may have messed up a little bit. So I'm going to plug back into that first one. So we've got x plus 3, and instead of y, I'm plugging in negative 43 over 9 equals negative 7, right? So x is fine on its own. If you remember, because we don't want to do it on a calculator and just get a decimal out, right? We want to be exact right now. So think back to how we multiply fractions. We can stick 3 over 1. So this is going to be negative, right? Because the 3 is positive, but our fraction's negative. So it'll be minus. And then I need to do 3 times 43, which gives me 129 over, and 1 times 9 is 9. That equals negative 7. And then I can add 129 over 9 to both sides. And now I get that x is equal to, and now it's okay to do it as a decimal. And I get 7.3 repeating. So I can stick this in a point now, 7.3 repeating. I could plug my y in as a fraction, or I can just do it on my calculator again and get the decimal. So it was 43 divided by 9, that was 4.7 repeating. Oh, and negative 4.7. And there we go. And if you took that point and you plugged it back into both those equations, you would get the right answer out. Right? If I do 6 times negative 4.7 repeating plus 5 times 7.3 repeating, I'd get 8. And same thing with plugging in the second one. So we want to be as exact as we can. Okay, so we've got a story problem here. You pay $22 to rent 6 video games. The store charges $4 for new games and $2 for old games. How many new games did you rent? Okay, so you need to, the two things that we're working with, right, are old games and new games. So those are the things that are going to be our variables. So I'm going to call new games x and older games y. And I need to start setting up an equation. Well, if I buy one new game, that costs me $4. If I buy 2 new games, that costs me $8. If I buy 3 new games, that costs me $12, right? What am I doing there? I'm multiplying. So we're going to have 4x plus, and the same thing for the older games, so 2y. And it says that we spent $22. So equals 22. Well, that's only one equation so far. I need to come up with another one. What number haven't I used? Well, I haven't used the number 6. And what's 6 talking about? That's talking about the number of games that I bought. So I know it's going to need to, my total of new games and old games is 6 games. So that's what my x is standing for. X is standing for the number of new games. Y is standing for the number of old games. So I get x plus y equals 6. And now I'm going to use substitution to solve this. So which equation do you think looks easier to solve for one of our variables? I think the second one looks easiest because they both have a coefficient of 1, right? X has a coefficient of 1 and y has a coefficient of 1. And then it's your choice which one you want to solve. We'll just solve for x. So I'll subtract y from both sides so that x is equal to 6 minus y. Now, x is the same thing as 6 minus y, right? So I can take that and I can plug it in for x. So I'm going to work up here. 4, and instead of x, I'm going to plug in 6 minus y plus 2y equals 22. And now I need to distribute that 4 in. 4 times 6 is 24. 4 times negative y is negative 4y plus 2y equals 22. So I'm going to simplify on the left first because I've got negative 4y and a positive 2y. So my 24 is still there, and that'll turn into a negative 2y equals 22. I'll subtract 24 from both sides. I get that negative 2y is equal to negative 2. When I divide by negative 2, I get that y is equal to 1. Which means that I bought one older game, I suppose. And then I need to plug back in to figure out how many new games I got. My second equation is going to be a lot easier to plug in, right? No division, multiplication, all that. So I get that x plus 1 is equal to 6. And when I subtract 1 from both sides, we get that x is equal to 5. So one older game and 5 new games. Okay, we can also use substitution to figure out how many solutions there are, if there's infinitely many solutions or if there are no solutions. So, we're going to take this guy. This one's starting to get a little tricky, right? Because none of those have a coefficient of 1. So, it's going to get a little bit messy. So, I think I'm going to solve my first equation since it doesn't have any decimals in it. So, I'm going to write it over here. 6y plus 5x equals 8. And I'm going to solve for x. So I'm going to subtract 6y from both sides. So I get 5x is equal to 8 minus 6y. And then I'm going to divide everything by 5. So x is equal to, and then 8 divided by 5 is 1.6. Minus, and 6 divided by 5 is 1.2. So this is 1.2y. So now I've got x on its own. So x is equal to 1.6 minus 1.2y. So I can take that and I can plug into our second equation. I can plug in for that x right there. So I'm going to write out that second equation. So 2.5, but instead of x, I'm going to plug in the 1.6 minus 1.2y. Still got that plus 3y and equal to 4. So I need to distribute it in, right? 2.5 times 1.6, that's 4. And then 2.5 times a negative 1.2y will give me minus 3y. And then I've still got my plus 3y equals 4. Well, I can simplify on the left, right? I've got negative 3y plus 3y. So this turns into 4 equals 4, which is true. If it is true, so if true, right, you get something like 5 equals 5. Negative 2 equals negative 2. If it's true, it has infinitely many solutions. If false, so if you get something like 3 equals negative 2, 5 equals 0, something like that, then there are no solutions. So in this case, we get something that's true, right? We get 4 equals 4, so that means there are infinitely many solutions. And whenever there's infinitely many solutions, that means these are the exact same equations. So, same equations, right? If we get no solutions, that means that they're parallel lines. So there's your homework.